Now let's check our other possibility, which was x equals 1. When we check x equals 1 in the original equation, that means we'll fill in 1 in place of x under the radical with the 8. We'll fill in 1 in place of x on the right-hand side. Under the radical we have the square root of 9, which is 3. 3 subtract 1 on the left, which is 2. On the right we have 2 times 1, which is 2. This one checks out just right. And so that means the answer is just the x equals 1. We omitted negative 7/4, which did not check. These two examples have illustrated the fact that with the two answers we get from a quadratic equation, possibly one of them works, possibly two of them work. In fact, it's possible that neither will work. We can have radical equations which have no answers that work at all. Let's go to another example. In this case we have a radical on both sides of the equation. This is the square root of x plus 2, add 1, equals the square root of 11 subtract x. Our first job is to isolate one radical on one side of the equation. Notice that on the left-hand side we have a radical with 1 as an extra. On the right-hand side we have another radical. On the right-hand side the radical is already isolated. We can't get the other radical alone without ruining the isolation of the one on the right. So all we can do is have one of them isolated. We've already got that, so let's leave it as it is and raise both sides to the power that matches the index of the radical. These are square roots, and so we will square both sides. So in both cases we square the entire side. Now that's a mess because on the left-hand side we have two terms. One is the radical, the other is a constant 1. We want to square this, which means that we want to multiply it by itself. So we have the square root of x plus 2, add 1, times another just like it, square root of x plus 2, add 1. On the right-hand side the square and the square root have canceled and we have 11 minus x. Left-hand side, we must use the FOIL method. When you multiply the square root of x plus 2 times itself, we get the square root of x plus 2 squared, which is x plus 2. Outer terms will give us 1 times the radical. Inner terms will give us 1 times the radical. That makes 2 times the radical. And then last terms will give us 1. So here's our result. The x plus 2 that came from multiplying the two together. Then 2 times the radical, which came from 1 times the radical for the outer and 1 times the radical for the inner. Here's our 2 times the radical. And then the last terms gave us 1. Now we have an equation which is not quadratic, but this is a radical equation. This means that we must isolate one radical. Here's the radical term. We must get that term by itself. That means we must subtract x from both sides, subtract 2 from both sides, and subtract 1 from both sides. When we do, we get 8 subtract 2x on the right, and the radical term 2 times the square root of x plus 2 on the left. We now have one radical term isolated on the left-hand side. We can now square both sides. Let's square both sides. And notice that on the right we must use the FOIL method. On the left we have a constant times a radical squared. Since these are multiplied, the square does affect each term separately. Notice the difference here. A coefficient times a radical, the expression squared, the coefficient is squared, and the radical is squared. A two-term expression, this must be multiplied out by the FOIL method. Two terms connected by subtraction, so that requires the FOIL method. So on the left we get 2 squared, which is 4, the square root of x plus 2 squared, which is x plus 2. Notice the parentheses. These are not optional, they must be there. On the right, when we use the FOIL method, we get 64 subtract 32x add 4x squared. We now have a quadratic equation. Notice the x squared. We must now get standard form, and so we simplify by multiplying the 4 by the parentheses, 4x plus 8. On the right-hand side, I have rearranged these terms because it feels more comfortable to have the x squared term, then the x term, then the constant, instead of having them in reverse order. Now we can subtract 4x plus 8 from both sides, and that gives us 0 equals 4x squared minus 36x plus 56. This can be solved by factoring or the quadratic formula, but if we look closely, we notice that there's a common factor of 4, and so what I'll do is divide every term on both sides by 4. This gives 0 equals x squared subtract 9x add 14. Now we have a rather simple quadratic equation which does factor nicely into x minus 7 times x minus 2. This gives us either x minus 7 equals 0 or x minus 2 equals 0, which gives us x is 7 or x is 2. Now that we've solved that long problem, we must check the answers. 7 and 2 are our possibilities. We need to find out whether either or both will work. Let's check the x equals 7. We check in the original equation. The square root of x plus 2 add 1 equals the square root of 11 minus x. We're going to fill 7 in on the left-hand side, 7 in on the right-hand side. On the left-hand side we have 9 under the radical. On the right-hand side we have 4 under the radical. Square root of 9 is 3. So on the left we have 3 plus 1. Square root of 4 is 2. So on the right we have 2. This gives us 4 on the left and 2 on the right. Not true. So we throw out the x equals 7. Now let's check the other possibility, which is x equals 2. The original equation. Then we fill in the 2 on both sides of the equation. The square root of 2 plus 2, add 1. The square root of 11, subtract 2. On the left we have 4 under the radical. On the right we have 9 under the radical. On the left we have the square root of 4 plus 1, which is 2 plus 1, which makes 3. On the right the square root of 9 is 3. This one checks just fine. This means that our answer is x equals 2. Now it's your turn. Exercises. The first exercise in our set to solve for x is the square root of x plus 1 add 2x equals 8. The second is x equals 3 times the square root of x. The third is the cube root of, in parentheses, x minus 2 squared, subtract 1 equals 0. Cube root x minus 2 squared, subtract 1 equals 0. Copy these 3 exercises, stop the tape, work the exercises, and then restart the tape to check your answers. Here are the answers. For the first exercise, x equals 3. Next, x equals 0, or x equals 9. And for the third one, x equals 3 or x equals 1. If you could not get these answers or you have questions, please see your instructor or your professor or a math tutor. It's the end of Math Tape 133.